Today we're going to talk about scientific notation. We use scientific notation a lot in science, chemistry, and physics for sure. When we're starting to talk about very tiny things or very large things, we don't want to write all those zeros, so we use scientific notation. It just makes math a lot easier, honestly. And any of you thinking about taking some of the, maybe an MCAT or DCAT or something, scientific notation is a great way to be able to see numbers and to do that mental math very fast. So well, you're going to have two parts. You're going to have the coefficient part and you're going to have the exponent. And this number here should always be a 1 to 9 number, so it should not ever be more than 10. So you always have a 1 to 9 number and then maybe a decimal and then another number, but this number before to the left of the decimal should not be bigger than 10. That's pretty much the rule. Then you'll have times 10 to a power, and that power will either be positive or negative. If you say positive, that means that you're meaning times 10. So right now this is saying meaning times 10 times 10 times 10. So anytime it's a positive value, you're going to get a much larger number, so a positive exponent. So anytime you have a negative exponent, you're going to get a really small decimal when we send it back the other way. So you can read through the notes that I've uploaded, but we're just going to work a couple of the practice problems. Scientific notation is very easy. You'll learn to use it with your calculator, but you also need to learn to use your brain a little bit. So we're going to be putting these numbers in scientific notation, and we're going to be taking these numbers out of scientific notation and putting them back in a regular number. So right now we have a quite large number of 17,600, and we have a decimal, but it is not visible. It is here on the end, and so to put it in scientific notation, again, you need to move it, so it's right there, and we're going to be moving it so that we get a 1 to 9 number to the left. So we're going to have to go 1, 2, 3, 4 spots, and so you're going to go 1.76 times 10 to the, and this was 17,000, which is a much larger than 10 number, so it will be a positive 4. That seems to be what students have the hardest time with, it positive or negative value. This beginning number here is a decimal number, so anytime you have a decimal number, when you put it in scientific notation, then it's going to be a negative exponent. So we're going to move it 1, 2, 3 spots, so 1.35 times, and that was not more than 10, so then it would be times 10 to the negative third. The negative third tells the calculator basically, or you, to divide by 10, to divide by 10, and divide by 10. And that's how we would get a decimal number. This tells our calculator to multiply by 10, multiply by 10, multiply by 10, and multiply by 10, and there you would get 17,600. So just think about your exponents of whether you're multiplying by 10 or dividing by 10 to get that value. Now this right here throws students for a loop. The fact that it's negative doesn't mean anything to the power, so if it has a negative in the front, you just put that negative there. It does mean something on the number line, but as far as the exponent, it doesn't matter. So I'm just going to put that, and I'm just going to look at the number of 607.30. So let me just scoot that little thing off. So I'm going to ignore that right there. So I'm looking at 607.30. So I need to move it, and I'm going to move it 2 spots, so 6.0730, and I'm going to keep that ending 0. If you watch significant figures, you'll understand why. This particular one has 5, so we need it to stay having 5. So then times 10 to the, and how many spots? We moved it 2, and it's going to be to the positive second because 607 is greater than 10. We're again ignoring that negative. We're just going to put that in front. We've got 4.76. We're not needing to move that at all. So anytime you need to put that in scientific notation, which you really would never need to, but your calculator sometimes will tell you times 10 to the 0 power, and so anything, if you don't need to move it, it's to the 0 power, because 10 to the 0 power means times 1. So there's the correct answer for those. Now go in the other direction. If it is a negative power, this means you're telling that we want to divide by 10 twice, meaning this number is going to get really small. So we wouldn't want to go to the right because it's getting small, and that would be getting larger. So we're going to move it 1 and 2 spots. We'll put our decimal and then fill in a 0. So we get 0.0496. And that's when you're putting it in normal notation. This is to the positive 4, so our number is going to get big. So you're going to move it 4 spots. There's 2. And I got to move it 2 more spots. We'll fill those in with zeros. So you get 5, 5, and then 3 zeros behind that. I'm not going to put that decimal. Again, you'll understand that when we do significant figures. This one's saying we don't have to move it at all, so it's just going to be 701. Again, super, super easy. So I do also want to show you how to correct, because some of you, again, will take tests that sometimes will not allow calculators, and to be able to correct it mentally in your head is a good thing to do. And so it says if you move your decimal to the left, add to the characteristic, also known as the exponent, and if you move to the left, your exponent is going to be getting larger. You can remember L and L, and right, reduce. So kind of the same concept with before. This is a larger than 10 number, so I'm going to move it. I'm moving it 1 spot. So however many spots you move it, you're going to add to your exponent. So I moved it once, so I'm going to add 1. So we would get 3.67 times 10 to the second power. This one's a decimal, so I'm essentially going to subtract or go to the negative direction. I am moving 2 spots, so I'm going to subtract 2 from this. 1.5 times 10 to the third power. Okay, that's correcting, because sometimes when you do mental math, you'll get improper scientific notation. Now, your calculator should never give you improper scientific notation, but it might. No, your calculator won't. But if you're not using a calculator, your brain might. So that's actually a better calculator anyway. Alright, if you're multiplying, and this is what you would do on some of those standardized tests without a calculator. If you're multiplying in scientific, you're just going to multiply those coefficients. 2 times 3, so we're just going to multiply that. 2 times 3 is 6. And then when they're in scientific notation, you just add those exponents. So a negative 3 plus a negative 4 is a negative 7. Alright, so we've got 5 times 4, 20. And then 2 plus 4 is 6. Alright, anything wrong with that? Well, our number needs to be 1 to 9, and 20 is not 1 to 9, so I have to do what we did up here. We're going to need to correct it, meaning it can't be that, so we're going to need to move it. We're moving it 1 spot. Since that was more than 10, we are going to add. So you would get 2 times 10 to the 7th power as the correct answer. When you're dividing, you do the same thing. You divide the front numbers, the coefficients, also called the mantises, and you subtract your exponents. So let's look at some of those. Alright, so we've got 8 divided by 2. 8 divided by 2 is 4. And then you're going to subtract these numbers. So you have a negative 5, and you are subtracting a negative 3. So 2 negatives make a positive, and so this is going to come out to be negative 2. Alright, many times I give this to students and they give me 2. 1 divided by 2 is not 2. 1 divided by 2 is actually a half, so it's technically a 0.5. And then you subtract your numbers. Let's go side by side then. 3 minus a minus 3. 2 negatives make a positive. So 3 plus 3 is, whoa, not 16 there. 10 to the 6th power. Anything wrong with that? Yep. we don't have a number to the left of this decimal. So I'm going to move it. Since this was a decimal number, I'm going to subtract 1. So you get 5 times 10 to the 5th power. Alright, that's pretty much the gist of scientific notation. Hope the video helped a little.